Let's take specific values for this equation. Y is equal to B0 plus B1x. Let's take values of B0 and B1. Let's take the intercept to be 1.01 and sales to be 2.45. Now I've got an equation. This equation is sales is equal to 1.01 plus 2.45 multiplied by advertising expenditure. This is what is called a model. What's a model? A model is an equation of this kind that models the data, that gives a mathematical model for what is going on in my data and therefore in my business situation. So now that I have this equation, I've not told you how we got to this equation, but let's begin with the equation itself. Once we've got this equation, let's think about what these numbers are telling me. Begin with the slope. What this tells me is that for a unit increase in advertising expenditure, the sales will increase by 2.45 units. What is a unit? The unit is the unit in which advertising is measured in this equation, and the unit in which sales is measured in this equation. So in this equation, however my units are measured, advertising in dollars or in thousands of dollars, sales in units or in thousands of units, if there is 1 unit increase in advertising, there is a 2.45 unit increase in sales. This tells you what is the nature of advertising as a driver of sales. Remember that objective for linear regression? Key drivers. How is advertising driving sales? It is also the case that if there is a unit decrease in advertising expenditure, sales will be expected to decrease by 2.45 units. Perhaps we've been a little careless in the language here. I should say the expected sales or the average sales, just to be clearer. But in the equation is written just as sales. But remember, sales here, in prediction mode, predicts an average sales. So if I have an advertising expenditure, I can also use this equation to predict sales. But for now, I'm simply using it to understand to what extent is advertising expenditure a driver of sales. This interpretation is valid only if the linear regression holds true or it is a good estimate. Strictly speaking, there is no way that the linear regression is true. We've seen that in the graph. So therefore, what do statisticians mean when they say that this equation is valid and this equation is true? They mean something a little more careful. They mean that there are certain assumptions that go behind this, and that those assumptions of linear regression hold true. We're not going to go into the details of what these assumptions are. But for now, it's safe to think of these assumptions as assumptions that allow me to justify the existence of a straight line, and to say that a straight line is a good representation. And if the straight line is a good representation, this is a good straight line. Again, we'll see where these numbers come from. So remember that a linear regression is built with certain assumptions. And a data analytics team, when doing this job over large data sets or looking at the stability of models, is tasked with checking these assumptions and see whether they are still valid or whether these assumptions are beginning to break down as more competitors come in, or as products become more complicated, or as the data becomes easier or harder to collect. So what about the intercept? I talked about the 2.45. If I have no marketing expenditure, if advertising expenditure is 0, in other words, if I put in 0 for advertising expenditure, now my predicted sales or my estimated sales is 1.01. In other words, this is the amount of sales that I would expect to get if I did not advertise. And that was something that was there in my graphs as well. In this particular case, this makes sense because it makes sense that even advertising provides a lift on sales. But even without advertising, I may have a base amount of sales. But in many cases, an intercept may or may not make sense of this kind. And if the business context changes, then an intercept may need to be thought of a little differently. Here's another equation just to help us see whether these interpretations hold up. Let's step away from the advertising and sales context into a different context of predicting the price of a house using input variables or predicted variables. To simplify the discussion, because we're talking about simple linear regression, let's look at only one predictor which is square footage. And the basic idea should be that the larger the house, the more expensive it is. You know that this is not always strictly true. You could have a house that is in a great location and is smaller and therefore is priced more. So this is a statistical relationship, statistically on an average, or shall we say averaged over other variables. Larger the house is, greater is the price. And let's say that I have this equation, 291.07 plus 105.45 into square footage, floor area. Now, what this means is, of course, from the intercepts perspective, is that if the square footage is 0, then the house price is 291.07, which may or may not be very meaningful. But from a slopes perspective, if I have a unit increase in square footage, the price of the house increases by 105.45 units, again in the units that I have. Again, assuming that the assumptions of linear regression are true. So it isn't always the case that all the coefficients are meaningful, but it still tells you to what extent is average house pricing going to depend on square footage if I have no information on the other variables, or if the other variables are averaged over. Many ways to think about that. But that is what that 1.45 means. As we just said, for the intercept, if there is 0 square footage, I will still have 291 as a house price, which may or may not make a lot of business sense at this point in time. So once again, the intercept is something that needs to be looked at with a little more care. The main reason for it is that this equation is built assuming a certain set of values for square footage, where the equation is meaningful and where the assumptions of linear regression hold. But 0 square footage is not one of those square footages which is in this meaningful region. So the equation may not actually make sense here. So the mathematics of it may be meaningful, but the interpretation of it may not be. So think carefully before you set about interpreting a coefficient. A slope is easy to interpret. It's the change in y given a unit increase in x, the 105.45.